So next up is clustering in data streams after finishing the introduction. And we will have 4 types of approaches or classes of patterns. And I see change detection is a kind of novel pattern you want to find. We talked about that we want to monitor also the changes of patterns, and change detection is dedicated to this one here. Okay, so clustering in data streams. Well, the basic idea is, that was a jump too long. Sorry for that. So the basic idea is first of all, back to the roots. So first of all, an overview here. So we talked about the batch methods. So the batch clustering problem is obviously given a set of data points, measurements, observations, whatever. The goal is to group these observations, these measurements, these objects into groups of similar data objects, which are the clusters. But that is the batch clustering problem, obviously. Now, in the stream setting, the clustering problem is that we have to maintain a consistently good clustering continuously of the sequence observed so far, of the sequence of data sets, of data objects so far. And doing this using considerably small amount of memory and time, obviously, because we have this resources constraint thing in the stream environment. So this implies that we obviously need to use incremental computations. We cannot access the entire data set as we want to, but we have just this one look at the data, and this means that we have to use incremental computations. Typically, we have to maintain cluster structures that evolve over time, not only batch cluster structures that are there and that's it, but they may evolve. And typically, since those cluster structures have to be approximated because the time and the storage constraints, the space constraints are too hard, we typically work with summaries of such cluster structures that should evolve over time instead of working with the raw data, obviously. So we typically work with summaries, and we will see that in all of the examples we will have a look on the next slides, that all those work with summaries of cluster structures instead of working with the raw data. And the point is, since we have this one look, one shot thing, that points or objects that coming in through the stream have to be processed in the context of those summaries, whatever that means. We will see that, as I said, right in a minute. So what are the challenges? Well, just a few, but the most important probably. So traditional clustering methods require access upon the whole data set. We don't have access to the entire data set, which is potentially infinite. So rather we need online maintenance of patterns and structures that captures pattern drifts. So if we have evolving patterns, evolving structures, the underlying population distribution might change. That is the problem of concept drifts, shifts of concepts. So also the story of clusters that change over time, patterns that evolve, change over time. One clustering model might not be adequate to capture the evolution. So it may be that for a given time slot, in an ideal case, one specific cluster model is best. So for example, the data distribution follows, for example, K Gaussian distributions, so an EM Gaussian mixture model clustering would be perfect. But then for some reasons the data distributions change, and the patterns change to form arbitrary oriented stuff, and then DB scan would be better. And of course this is a very, very hard problem, because typically we just apply one specific cluster model on the entire stream or during the entire lifetime of the stream. So changing the cluster model is extremely challenging and extremely hard to do. Then the role of outliers in clusters, which are somehow orthogonal concepts, are often exchanged in streams. So things that have been outliers become clusters, because in that region a lot of observations appear during time, and the other way around. So clusters that are there in an early stage of the stream, in an earlier time period, may get, some of those points may get obsolete, some of those observations, and then the remaining observations become outliers. So we have to take care about that. And of course, the key to success is a clear and fast identification of outliers, because since we want to work with summaries and just focus on the clusters, it is very beneficial if we see that if a point is arriving, we could distinguish this point as an outlier. So obviously very soon, very quick, is obviously beneficial, because then we can just discard it. So that is also one of the challenges here. Yeah, and we will see some different methods which follow different cluster models. So we will have methods that follow the partitioning-based cluster model. So the batch or static clustering methods will be k-means or k-mediates, and the corresponding stream clustering algorithms we will have a look on is leader, stream k-means, and clue stream. Then we have some methods for the density-based cluster model. The batch clustering algorithms, probably is dbScan and optics, for example. And we will have a look at dense stream, incremental dbScan, and incremental optics. Just a very short, we will only have a look at dense stream, but there are also incremental versions, more for a data warehouse environment, of optics and dbScan. And then we have the grid-based methods. So string, for example, is one of the batch clustering algorithms, and we will have a corresponding stream variant, which is called dstream. So we will have a look at that also. Yeah, so a short overview. Typically, the goal is to construct a partitioning of a set of objects into k clusters for the partitioning-based approaches especially. And they are typically, but also for the density-based things, where k is then not an input parameter, of course. And typically, we have two types of methods, even though we have 3 bullet points here, but the latter two here are the same type of methods. So the first type of methods use a kind of adaptation of traditional clustering methods to streams, which typically end up in some kind of or so-called single pass algorithms. So each data object is only processed once, which is a single pass algorithm for the batch scenario, and that can obviously applied to streams, as long as each point is only processed at a time and only once. Then they can be applied to streams. And the second class of algorithms use an online-offline, two phases, online phase and offline phase, where the online phase typically works with summaries. So also the continuous grid-based approaches work with summary information, and this summary information is maintained during the stream processing. And at a given point in time, you can have a clustering offline then, so parallel to the further evolving stream. You can have an offline clustering method or offline clustering of the summary based on the summary information. So you have those two phases: the online phase that just works with the stream and just maintains some summary information, and then an offline phase that can be triggered as long as you want it, which works or computes a clustering based on the current summary structure or the summary information. And we will also have a look at those things. So those are basically the adaptive approaches, which will be next, and online-offline approaches, including the grid-based approaches, will be second next. And at the end of this subsection on clustering, we will have a look at change detection, a very short look actually on change detection.